Okay, our final example today, verify the identity cosecant of 2 alpha equals 1/2 of tangent of alpha plus cotangent of alpha. Again, we have this option, should I pick the right hand side or the left hand side? And again, I can go with either side and get the right answer. Let me just say that to begin with. A couple things I consider to make my decision for me. I find it easier to put things together than to take things apart. So if I'm trying to go, if I have 2 terms on this side and only 1 term on that side, I think it's easier to go from 2 to 1 than it is to go from 1 to 2, typically, usually. All right. But cosecant of 2 alpha has, you know, some of these trig functions have the ability to split into 2 pieces anyway, so maybe it's easy enough to do that. I would probably start with the right-hand side personally on this one. That's me. So if I start with the right-hand side, 1/2 times tangent of alpha plus cotangent of alpha, left-hand side. All right. What do we think the first thing we can do is?
Go to cosine and sine form?
Yeah, cosine and sine form. If you got nothing else that you can think of, that's always a good plan. All right, so if I got anything that isn't sine and cosine, just change them into sine and cosine, see what happens. I'm not trying to get to a sine or cosine form, but I can change that back to cosecant easy enough. So that's usually a good place to start. So 1/2 times, this will be sine of alpha over cosine of alpha plus cosine of alpha over sine of alpha. And that's just going to be numbers 1 and 3. Tangent being sine over cosine, cotangent being cosine over sine. Next thing is, when you have an option, you have fractions, it's better to have fractions added together than it is to have them separate like this. Unless you need to separate them, unless you need to go from 1 term into 2 terms, then you might need to separate them. But we're trying to go from 2 into 1, so the fact these are separate terms here, adding them together to make one single fraction seems to be a reasonable plan. So I think you guys have the ability to add fractions mentally. If not, use a scratch sheet of paper. But if you just want to give me the addition, the sum of these 2 fractions, multiply top and bottom of this by sine, I'm going to get sine squared over sine cosine. Multiply top and bottom of this by cosine, I get cosine squared over sine cosine. So altogether, I'm going to get sine squared alpha plus cosine squared of alpha all over sine of alpha cosine of alpha. And the justification there, add fractions. Okay. And I'm fine with that. If you want to just add fractions in one fell swoop, again, if you can do it mentally, great. If not, use a scratch sheet of paper, figure out what it is. Go from this structure to the added, simplified version of that addition of fractions. Okay, what else can we see here?
The top can go to 1.
Top equals 1, that's usually promising. So let's try that. So I'm going to get, that equals 1, so that gets me 1 over 2 sine of alpha cosine of alpha. And that's by number 5, right? We're trying to get into cosecant of 2 alpha, right? And if we just, again, this is scratch work here. This doesn't show up in my real work because this is kind of cheating a little bit. But if I know that cosecant, helps if I use the right abbreviation, cosecant of 2 alpha is just 1 over sine of 2 alpha, right? And look at the bottom of this. 2 sine of alpha cosine of alpha is exactly that, isn't it?
Mm-hmm.
So what I have here is 1 over sine of 2 alpha. And that's by number 35. So then our final step is 1 over sine of 2 alpha is the same as cosecant of 2 alpha, and that's by number 4. In order to start with the left-hand side here, we would have had to go to here, then to there. We'd had to recognize that that's sine squared plus cosine squared. So again, that's where the 2 terms are coming from. And then that 1/2 gets extracted out, which I might have thought of because there's a half extracted out there. I might have thought of doing that, but maybe I wouldn't. I don't know. Then you split the fractions apart, reduce, and then you get to the tangent. It's harder to go from a single object to multiple objects typically, so usually I don't want to do it that way. Okay. There are some certain circumstances where I would, but that's not one of them.